Good job, folks. Let's see. So you guys did pretty darn well on this. Nice job. So here, this is how I kind of want the trees. I haven't really gone over with you guys enough, just because there've been so many things we're trying to cover. But here are your options: low, medium, high. Those are destinations, right? The probability of getting there is what I want on the branches, just like this. Low, 0.6 chance. Medium, 0.3 chance. High, 0.1 chance. Then, if I'm here at low, I can go yes or no for the accident. So 0.1 chance of yes, 0.99 chance of no. Right, so this is beautiful, just like that. So then they found these probabilities. So it's it could be accident with a low, or it could be accident medium, or it could be accident high. These three items, and they had to think about it. Whether that was an and problem, is it the probability you're low risk and had an accident, and you're high risk and had an accident, and you're medium risk, or were you low risk with an accident, or medium risk with an accident, or high risk with an accident? And they correctly figured out that it should be or, right? You're going to be one of them. So that's why ors we do what, guys? Ors we add.
Or you add.
Perfect. So then they added these up. All right. So here, this is low risk and an accident. So that's why I multiplied 0.6 times 0.01. You multiplied because it's low risk and an accident, medium risk and an accident. So these are all multiplications because you're ANDing them. And then you're ORing those because it's either accident low, accident high, accident medium. So you're ORing those. So you're adding those guys. Terrific.
Professor,
yeah.
Would you be able to go over how to figure out if it's an or an and problem again?
You have to sort it through and figure out, well, am I taking this person or that person? Do I need this to happen or that to happen, or do I need both of them to happen? If they both have to happen, then that's an and. But if either this happens or that happens, either one, then that's an or. Does that make sense?
Thank you.
Yeah, no, good questions. Great. Next, we're going to take a look at conditional probability. Right, so this is, we're just going to do the very basics of Bayes' theorem, the initial case, the base case. We're not going to do anything fancy with it because we don't, we're going to try to stay conservative this semester a little bit. So conditional probability, how about, let's get a reader. How about Sky? You haven't read for us yet. Why don't you read for us? Just the green box.
Conditional probability, P.
Probability of
P given A equals P.
Probability
of A and B over the probability of A.
Great. So again, that's probability. That means that the probability that B occurs given A has already occurred. So how do you find this? This comes from this standard and equation you guys had earlier. You've seen a bunch of times. All I do is take this, divide both sides by probability of A, and you get this up here. All right, because the probability of A's will cancel out. So it's nothing new, nothing fancy. If I multiply both sides by probability of A, this would go away, and this would become that AND equation we saw right here. It's just this one right here. Okay. You can use this. Personally, I think it's a lot easier just to look at your problem. If I say, what's the probability of that you had an accident given you're a low risk, I think it's a lot easier to just look at this number here and say, oh, given I was low risk means that I'm standing, let's pick someone who's got a bigger, I need a larger, yeah. All right, so probability of low risk means that it's probability of accident given low risk. Given low risk means I am standing here. 100% I'm here if I'm given low risk. So probably I have an accident at this point is just this spot right here, just this 0.01. It's a lot easier to find that than it is to take the probability of them both happening and dividing by the probability of A. If I took this divided by the probability of A, probability of low risk, 0.06, or 0.60, sorry, 0.60, I would end up getting 0.01. So you could do it that way, but it's a lot easier just, if you have a graph, just look at it and find it from there. But this is an alternative way you could do it if you forgot that. All right, so what I kind of want you guys to work on now is lab problem 17. There are 3 red marbles, 1 green, and 6 blue. Don't forget the green ones. Now there's 3 different colored marbles. You're drawing a marble. You are not replacing it. Replacement means you draw a marble and you put the same marble back. Without replacement means you draw it and you keep it. Go ahead and find these probabilities, and we'll go ahead and, if you finish that one, then work on the next couple pages, which is quiz problem 6 and 7. So go ahead and hop in. And if you need if you need help, just ask me for help, and we'll send, either I'll go or Angel will go, and we'll work with you guys. Or you can request her right away if you want. If anybody feels a little bit unsure about this, feel free to ask for her right now, and we'll send her in.
You have me in breakout room 9. Is that where you want me to go?
Hello. Like everybody's back? Great. So here is, I mentioned this to a couple groups, but not everybody. Another way you can do it is you can actually take a picture of your work and upload it. There's this little button here, the little one that looks like a mountain, looks like a picture, right? If you click on that one, you can add an image, and you can, put an image up there from your, from your device, and then you don't have to draw all these trees out. Speaking of trees, what I want is, I want the destination, like my options are red, green, or blue at the ends, and then the probability is on the branches. So here I'm going to move this one so it's kind of on the branch a little bit. I might tilt it a little bit too. So then the probability is on the branch, and then the end, the R is kind of the destination. Does that make sense? So that's kind of how I want them to do this. This is great, so you guys realize that now there's only, once you pick a red one, now you only have 9 left. 2 are red, so 2 nines red, 1 nine's green, 6 nines blue. If you picked a green one, now you have, again, 9 left, 3 red, 0 green, 0 out of 9 green, and 6 out of 9 are blue. Perfect. If you guys did not get this down here, then you should fix it, because this is going to be important for the exam. I feel like people were pretty good about this. What's the probability you did a red one, then a green one? So that means that I went along this pathway, red, and then, Do you guys not want me writing on yours? I can not write on yours. I can write on somebody else's if you want. Red and then green. So you're going to multiply along the probabilities. 3 over 10 times 1 over 9, you'll get 3 over 90. On the exam, you can enter it just like this as an unsimplified fraction that's perfect, or as a decimal rounded to 3 decimal places. What's the question?
Why are we multiplying?
Because it's red. Red. Because red then green? Did I do both of them, or just one or the other?
Oh, okay. Never mind.
So if you have to do both of them, I draw a red one and then I draw a green one. They both had to happen. Then it's an and. That's a great question. If they both had to happen, it's an and. If it's just one happened or the other one happened, either one happened, then it's an or. Good. Let's take a look at red given blue. So given blue means I am standing here. What's the probability blue has happened? 100%. Given blue means I know blue has happened. So the probability of blue happening is 100%. I am here. What's the probability that I draw a red one? 3/9. Done. Questions about this? So given blue, you know you are here. You're given information. From here, then you just find the probability. Probability of red, straight up, just 3/9. That's it. Super simple. Don't make it harder than it is. It's very, very straightforward. It's not as complicated as it sounds, right? Both the same color. How do you get both the same color? Red, red, green, green, or blue, blue. Let's see if somebody actually found all those pieces. I'd like to find the small pieces individually. Here we go. All right, so red, red. That's this one here. And then blue, blue, that's that one there. And the probability of green, green is impossible, 0, so they left that one out. So it says 6/90 plus 3/90, 36/90. So you can either leave it like this, or like that, or you can give me the decimal. I don't care. Any one of those is fine. And then red on the second draw. That's a tough one, huh? I'm not sure everybody got to that. Oh, here it is. These guys got to it. Great. So they said, let's see, red on the second draw. That's this guy, and that guy. So you find those probabilities. 3 times 2 is 6, 6/90. 1 times 3 is 3, so 3/90. 6 times 3 is 18, so 18/90, and you add those up, and you get your answer. Again, you can just do this using decimals. I'm fine with it if you added those as decimals and got a decimal answer. I don't care. This is not about can you multiply fractions and can you add fractions. I just care that you know to multiply these things, and just let your calculator do it with decimals. That's absolutely 100% fine. Totally okay.
Could you, so we're just multiplying across the,
Yeah, so if I want to find here, I multiply along this branches, so I'm going to multiply here, and I multiply, should be right here, but they moved it over here, that's fine.
because that's the second draw, right?
Yeah,
That makes sense.
3/9. Just multiplying those two numbers.
And then since we got 0, we were stuck on that one, so you could just leave that out.
Yeah.
No answering.
Mm-hmm.
Okay.
Good. Questions about any of these? These are questions, similar ones you might get on the exam, so just make sure you understand this stuff. Take a picture of this if you need it, or watch the video. Okay, so now what I want to look at is we have 8 minutes left. I'd like to law of large numbers. All right, let's see someone reading this one very quickly. How about Miriam? Can you read this real fast? Or Dylan. Or actually, Dylan has a broken microphone. Elizabeth?
If you flip a coin 10 times, you expect 5 heads, but very often you will get 4 heads or 6 or some other number. This is just due to randomness. The law of large numbers states that as we perform an experiment like flipping a coin, as your sample size increases, the observed probability will get closer to the true probability.
Yep. So law of large numbers does not mean that if it's come tails the last 4 times, the likelihood of heads the next time changes. The next flip is still 50-50. Right? The coin doesn't know, oh, I came tails the last 4 times, I better come heads now. It has no memory. Right? It's still 50-50. Did anybody get to quiz problem 6 or 7? No? All right, I'm going to send you guys out there just for 5 minutes, maybe 4 minutes, just to try those ones. I want to bring you back in so you have a chance to go over them because you'll need to know these for the exam, though. So I'll pull you guys back in pretty quick. Yes, it is right. Okay. All right. So very quickly, let's kind of go through these. So dice is rolled 5 times. Find the probability of getting no 4s. That means I roll it 5 times every time I fail. So probably getting a 4 is 1 out of 6. So it's probably rolling a dice and not getting a 4. 5 out of 6. But I need this to happen 5 times in a row. So it's not not a 4, and 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 we multiply. So I'm going to multiply 5, 6 by itself 5 times. You'll get 0.402. Now, remember, either you get no 4s or you get at least 1 4. Those are complements. So that means that they have to add up to 1 or 100%, which means that if I take 1 and subtract this one, I can get the other one. I can get the probably at least 1. So that's what they did here. Perfect. The other one is a little more complicated. I went ahead and did it a little bit myself. So here's what we've got. The probability of at least 1 girl plus the probability of no girls, right? Those are complements, has to equal 1. No girls is the same thing as all boys, right? So I need to find the probability of boy, 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 because at least one's hard to find, but no girls, easy. Boy, 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 so I need to find 3 boys in a row. There are 14 boys and 8 girls. That means that 14 out of 22 of them are boys. Now, how do I know if I can reuse items or not? Does it say it's 14 over 22 all the time, or does it change? If I say, hey, go grab me 3 kids off that bus, are you going to pick the same kid 3 times? Can you do that? No. Right, if someone said, hey, go get me 4 batteries out of the drawer, and you came back and said, here's 1 battery, I picked the same one 4 times, they'd look at you like you're crazy, right? When they say, pick 4 of them, that means pick 4 different ones. You can't reuse them. So you have to kind of realize that and say, okay, I can't reuse items, so this is going to be, now I only have, the second child I pick, I'm only going to have 21 kids to pick from, and only 13 of them are going to be boys. And then the next one is only going to be 20 kids to pick from, and only 12 of them are going to be boys. And then find this number and subtract it from 1 to get the probability of at least 1 girl. Does that make sense? So this is going to be, probability of at least 1 girl is going to be equal to 1 minus whatever this mess is, and I don't remember it offhand. Looks like this is 0.236. So that means that this is going to be 1 minus 0.236, which is equal to 0.764. Okay, that is it. Have a great couple of days. The other things I wanted to cover today that are, on your quiz thing up here, I'll cover those. We'll work on these ones in the, these problems here. We'll work on those ones in the review session. So if you want to try them to start with, well, actually, the first thing you want to do is do the study guide. The study guide is the #1 best way to prepare for the exam. So yeah, and don't forget to look at the solutions for that. What you're turning in today is quiz 4.4 and page 15 from your notes. So page 15 are the things you're turning in today. Page 15 on your notes and quiz 4.4. And we will see you guys. Don't forget to do your exam 1, part 1 test, and I will see you guys later. Have a good day.
Perfect.
Yeah.
Do you want both pages or just one?
Of the quiz, just the first page of the quiz.
Okay.
First page of the quiz, and then page 15. Good. Great. Thanks. Any other questions? All right. Take care. Good luck on the exam. Oh, also, one thing, if you have any problems during the exam, I will be available on Zoom, on our class Zoom. So come see me if you have a problem. Okay.
So the study session tomorrow,
Yes.
we're going to go over the practice exam, right?
No, we're going to go over, we're going to go over this. Review in class.
Okay.
And if you have any questions in the practice exam, I'm happy to go over those as well. Absolutely.
Okay.
Yeah. Totally.
Professor Young.
Yeah.
I'm sorry. When's the review session?
Tomorrow?
Yeah, when's the review session?
Tomorrow. So it is tomorrow.
Is it like 7 p.m.?
Here it is, right
I'm
here.
sorry, I don't know the time.
It's at the bottom. Can you see it?
Oh, okay.
Yep.
7:30.
6:30, 7:30.
Okay. Is it okay if I'm a little late?
Sure, absolutely.
Okay. Thank you.
You're welcome. let me go ahead and start recording this one. So if you're having trouble getting Proctorio to work with your camera, then you can do the camera part with me via Zoom. That works, but you have to let me know. You have to email me and let me know. And then you'll still take the exam on Canvas, and it'll be with Proctorio, but not with the camera part, just the regular Proctorio part, the non-camera Proctorio.
That sounds great, because I was just going to call on this computer and kind of like aim it towards my main desktop so you can see my hands. Okay, that's awesome.
Yeah.
The reason why is I use the Proctorio for my other classes, and they keep dropping me like a couple of times.
Yeah.
I'm trying to justify with the professor.
Right.
So I'm just trying to avoid it.
Sounds good. Good deal. Perfect.
All right, appreciate it. Thanks so much.
Oh, yeah. My pleasure.